Can you imagine that another version of you living in another universe? You may think it in a funny way, but can you believe that this has been rolling in the heads of scientists for more than centuries? The term multiverse was coined by American philosopher William James in 1895 in one of his essays, Is Life Worth Living? Our universe is unimaginably big. Hundreds of billions, if not trillions of galaxies spins through space, each containing billions or trillions of stars. Some researchers studying models of the universe speculate that the universe diameter could be 7 billion light years across. Others think it could be infinite. Real scientific theory explores the case for a universe outside, parallel to, but mirroring our own. Multiverse and parallel worlds are often argued in the context of other major scientific concepts like the Big Bang, string theory, and quantum mechanics. Around 13.7 billion years ago, everything we know of was an infinitesimal singularity. Then, according to the Big Bang theory, it burst into action, inflating faster than the speed of light in all directions for a tiny fraction of a second. Before 10 to the power minus 32 seconds had passed, the universe had exploded outwards to 10 to the power 26 times its original size, in a process called cosmic inflation. And that's all before the actual expansion of matter that we usually think of as the Big Bang itself, which was a consequence of all this inflation. As the inflation showed, a flood of matter and radiation appeared, creating the classic Big Bang firefall, and began to form the atoms, molecules, stars, and galaxies that populate the vastness of space that surround us. The mysterious process of inflation and the Big Bang have convinced some researchers that multiple universes are possible. Or even very likely, according to theoretical physicist Alexander Velikin, inflation didn't end everywhere. At the same time, while it ended for everything that we can detect from Earth 13.7 billion years ago, cosmic inflation in fact continues in other places. This is called the theory of eternal inflation, and as inflation ends in a particular place, a new bubble universe forms. Those bubble universes can't contact each other because they continue to expand indefinitely. If we were to set off for the edge of our bubble where it might butt up against the next bubble universe over, we'd never reach it because the edge is zipping away from us faster than the speed of light and faster than we could ever travel. But even if we could reach the next bubble, according to eternal inflation combined with string theory, our familiar universe with its physical constants and habitable conditions could be totally different from the hypothetical bubble universe next to our own. This picture of the universe, or multiverse as it is called, explains the long-standing mystery of why the constant of nature appears to be fine-tuned for emergence of life. The reason is that intelligent observers exist only in those rare bubbles in which, by pure chance, the constants happen to be just right for life to evolve. The rest of the universe remains barren, but no one is there to complain about that. In some of the finite bubble universe outside our own, there could be another intelligent observers, but in every instant that passes, we get farther away from them and we will never intersect. Some researchers base their ideas of parallel universe on quantum mechanics, the mathematical description of subatomic particles. In quantum mechanics, multiple states of existence for tiny particles are all possible. At the same time, a wave function encapsulates all of these possibilities. However, when we actually look, we only ever observe one of the possibilities. According to the Copenhagen interpretation of quantum mechanics, we observe an outcome when the wave function collapses into a single reality. But the many worlds theory proposes instead that every time one state or outcome is observed, there is another world in which a different quantum outcomes becomes reality. This is a branching arrangement in which instant by instant our perceived universe branches into near infinite alternatives. Those alternate universes are completely separate and unable to intersect. So while there may be uncountable versions of you living a life that's slightly different from your life in this world, you'd never know it. Some physicists believe in a flatter version of multiple universe. That is, if the universe that we live in goes on forever, there are only so many ways that the building blocks of matter can arrange themselves as they assemble across infinite space. Eventually, any finite number of particles types must repeat a particular arrangement. Hypothetically, in a big enough space, those particles must repeat arrangements as large as the entire solar system and galaxies. So, your entire life might be repeated elsewhere in the universe, down to what you ate for breakfast yesterday. At least that's the story. But if the universe began at a finite point, as nearly every physicist agrees that it did, an alternate version of you likely doesn't exist. According to the astrophysicist Ethan Siegel, the number of possible outcomes from particles in any universe intersecting with one another tends toward infinitely faster than the number of possible universes increases due to inflation. So this multiverse theory could relate with something called mirror image universe. It can be said like that: the universe began at the Big Bang, and on the opposite side of the Big Bang timeline, stretching backwards in time, a universe once existed that was the exact mirror image of our own. Instead of saying there was a different universe before the Big Bang, we are saying that the universe before the Big Bang is actually, in some sense, an image of the universe after the Big Bang. That means everything, protons, electrons, even actions like cracking an egg would be reversed. Antiprotons and positively charged electrons would make up atoms, while eggs would uncrack and make their way inside chickens. Eventually, that universe would shrink down to a singularity before expanding. Seen another way, both universes were created at the Big Bang and exploded simultaneously, backward and forward in time. Some of the arguments for the multiverse theory are: our universe grew exponentially in the first moment of its existence, but was this expansion uniform? If not, it suggests different regions of space grew at different rates and may be isolated from one another. How are the laws of the universe so exact? Some propose that this happened only by chance. We are the one universe out of many that happened to get the numbers right. What is beyond the edge of the observable space around us? No one knows for sure, and until we do, that our universe extends indefinitely is an intersecting one. Some of the arguments against the multiverse theory are: there is no way for us to ever test theories of the multiverse. We will never see beyond the observable universe. Sometimes, the simplest ideas are the best. Some physicists argue that we don't need the multiverse theory at all. It doesn't solve any paradoxes and only create complications. Not only can we not disprove any multiverse theory, we can't prove them either. We currently have no evidence that multiverse exists, and everything we see suggests there is just one universe, and that's our own. Countless works of myths and fictions draw from ideas of parallel universe and the multiverse. Overlapping worlds make appearance in Norse mythology, as well as Buddhist and Hindu cosmology. Parallel universes are no longer just a feature of a good science fiction story. They are now some scientific theories that support the idea of parallel universe beyond our own. However, the multiverse theory remains one of the most controversial theories in science.